Hello, my name is Kamyar, and in this tutorial I'm going to model a beam from this paper by using FEMIX PrePost application. First, I'm going to check the geometry of the beam. This is the geometry of the beam. It contains several beams. I have the beams here. I want to choose one of these beams. I want to select this beam, and for simulation we need to extract the coordinates of the beam and cross section. I want to assume left support as the center of the axis. It will be my 0, and for plane stress, because I want to model this beam by plane stress elements, the axis must be y along the beam and z in this direction. We are going back to the application. I will create a new file. We need to select the name. I name it beam1, save, and then we need to draw the different parts of the beam in the model tab. I want to divide the beam in different parts. I chose under the rebar layer as one part, from the rebar to the top of the web as the second part, and the flange as third part. Also, we have one layer of rebar at bottom, one layer of longitudinal bar at top, and also we have the stirrups and also 2 Z bar. I name it as web 1. Okay. For drawing, we need to select the type of that element. I want to model this beam as plane stress. So the beam section will be a 2D, two-dimensional element. I will choose 2D shell. Well, for drawing, we need to draw the points, and then we need to draw the surface. Now I click on point. Here in the command line, we see that we need to enter the point coordinates. I already noted the coordinates of this beam. The first point is 0, minus 200, and 0. I zoom fit to see the point. It's this point. If we assume this point as the center of the axis, this point will be 0, because we are drawing in YZ axis, so the x will be 0, the y will be minus 200, and the z is 0. And we need to introduce other points by the coordinates of the corners of that element. The next one is 0, 2000, 0, 2024, 0, minus 224. I zoom it again. Now we see that the point order are from 0, 1, 2, and 3. Now we have to create the surface. I click on surface. I could click on the point, and the surface will be created. And the next one, new part, is web 2. Okay, it's like the previous element, it's 2D shell. Now I click on point, so it says that enter point coordinates. The second coordinates are 0, minus 224, 0, 2024, 0, 2340, and 0, minus 200 and 340. We can also click on the edit by notepad and modify the points here. If we enter a wrong number, we can just modify it easily. For example, here I want to change one value, the last one, I change it to 100 and save this file, and then I will click on the name of the part again to be refreshed. Now we can see that the coordinates of the point number 3 is changed. And for deleting any item, also we can use the edit by notepad and just simply delete that line, or we can click on the delete icon and click on the point number, and we have to go back to command line. It says that, are you sure you want to delete this point? And if it's yes, by enter, it will be deleted. Now I'm going to add the last one again, minus 200 and 340. And I need to draw the surface. I click on surface, I can click on the point, or I can just write the number of the point in the command line. For example, the second point is number 1, I click on enter. The third point is number 2, click on enter, and the last point is number 3, and click on enter. And we will have the second part of the web. Now I need to draw the flange. I name it as flange. It's 2D element. I click on point. I will enter the vertices of the flange, minus 200 and 340, 0, 2400, 0, minus 200 and 400. Now we have the vertices of the flange. Now I'm going to create a surface. The surface started from point 0 to point 1, 2, 3. I just enter the number of points in the command line and click on enter, and the points will be introduced. Now we have the flange of this beam. Now we are going to draw the longitudinal bars in the bottom and top, and then the stirrups and the Z bar. The next one is the bar in bottom, which is a GFRP bar. Bar in the bottom, I will draw it as a 1D wire. It's a line element. First we need to create the points, the start and end point of that beam, of that bar. Here we see that it starts from 0, x is 0, and y is minus 200, and z will be 24 because the cover is 24. Zero, minus 224, 2, 0, 2024. Now I need to just draw the line because it's 1D elements. Now I have the bar in the bottom. The next part is bar in the top. Bar on the top. Because the coordinate of the bar in the top is just the z is different, I want to use different strategy. I want to copy this part, I want to duplicate it, and I will rename it to bar top. Now I duplicated the bar in the bottom, and I will modify the coordinates. The coordinates will be, for the Z will be 385. Save. Now if I refresh the bar and if I check the coordinates, I click on select icon and just click on this, and we see that the coordinates are refreshed and they are updated. It's 0, -200 and 385, which is actually the coordinates of the start of the bar in the top. And then I'm going to draw the stirrups. A stirrup. The stirrup is 1D, and I need to draw the coordinates of the vertices. It will start from, because we have different stirrup, we need to introduce the coordinates of a start and end of each section. The first one is 0, -20, 0, 0, -20, 400, 0, -170, 0, -170, 400. And I can continue like this by copying one of them, because the Z is common between different stirrups, and I will change the Y. It's 1, it's 1240, 1240. You can use different strategy for drawing the parts by using this input file, or by entering the data directly in the command line. 90 and 1390. Save and stirrup refresh. Now you can see that it already added the new points. I want to continue from the command line. 0, -0, 1540, and 0 to 0, 1540, and 400, 0, 1690, and 0 to 0, 1690, and 400, and 0, 1840, and 0 to 0, 1840, and 400. Well, it seems that they're correct. Now I'm going to draw the line from 2 to 3, and another line from 0 to 1, another line for drawing the old stirrups. It seems that the coordinate of last point is not correct. I will go and check. Okay, this is wrong. It should be 40. And yes, and I will refresh it, and now that's fine. Okay, I have to draw the last part, which is the Z bars. I want to use the coordinate of these stirrups for drawing the last part. I will duplicate the stirrups. it named as stirrup 2. I will rename it stirrup Z. Okay, and I'm going to draw from 4 to 9 and another line from 8 to 13, and I have to remove the unused elements because they are in a different part. Okay, we have the Z bar now. Okay, we already drew all parts of this beam. Now we can move to mesh tab. In the mesh we have the list of different parts. First I will mesh the web 1. We can check a structured mesh, or we can also mesh as an unstructured mesh. Let me choose web 2 to see the difference. First I want to mesh this part as an unstructured mesh. I will enter 30 millimeter as the prescribed mesh size, and I will generate the mesh, and we see that we have the unstructured mesh. I uncheck the node, and this time I will click on structured mesh and will generate the mesh, and now we see that we have the general structured mesh. We can also generate the quadrilateral or triangle mesh for triangle mesh. Now we see that we have a structured triangle mesh, but triangle and tetrahedron currently are not supported for different types of material by FEMIX, so it's better to use quadrilateral and hexahedron mesh type. And if we click on quadratic mesh, and after generating the mesh, we see that we have the quadratic 8 nodes elements, but for this case I don't want to use the quadratic mesh, so I just use the quadrilateral 4 nodes elements and structured ones. So the mesh is confirmed. I can add them to FEMIX. Now they already added to FEMIX. The second part, I want to use web 1. I don't want to change the options. I want to keep the mesh size and structured mesh and quadrilateral, and I generate the mesh. I want to check it and then send to FEMIX. Now we see that the mesh is already added to FEMIX. The third part is the flange. I just generate the mesh and add to FEMIX. Okay, now we are going to mesh the bars and add them to the FEMIX model. First I want to mesh the bar in the bottom. We can use the mesh option to generate the mesh, or we can use the auto mesh as an embedded element. If we use auto mesh as an embedded element, the mesh will be coherent. It means that the nodes of each element will be on the edge or on the nodes of its mother element. I will keep auto mesh and generate the mesh. Now we have the mesh and I will add it to FEMIX. Let me click on nodes to see the nodes. As you can see, the nodes of each element of this bar is on the corner of its mother elements, because we need to keep the mesh coherent for the embedded elements. The next part is bar in the top. I just generate the mesh and add it to FEMIX. And the next one is the stirrups. I just generate the mesh and add it to FEMIX. The next one is stirrup Z, and generate the mesh and add it to FEMIX model. Now we already generated the model, we meshed it, and now we can move to the FEMIX part. In FEMIX, we need to introduce the different properties of the model, and in order to generate the FEMIX input file. If I move to FEMIX tab on the bottom, we will see we already have the point coordinates which imported from the mesh. We have the element nodes, we have the element properties which needs to be completed because it's not complete yet. They already imported from the previous part, and we have the groups which are already the different parts of the model. We can use this editor for modifying the model, or we can use this tree view by double click on each part. If I double click on group, I can see a table which include the list of different parts, and if I right click on this table, I have some options. For example, I want to edit one row. If I select the row and click on edit, I can modify the name of the group, or I can add a new group. For example, I want to add a group called beam. Okay, now we have the beam here, and if I click on OK, we will see that the beam is already added to the model. And if I modify the beam name here, beam, for example, I change it to conch beam, and if I go back to the model, I will see that the name is already modified. But first, we need to modify the main parameters. For main parameters, we need to choose a name. I will choose beam. The analyze type is static, and I want to use material nonlinear problem. And for material nonlinear problem, I accept the default values, and I want to check the arc lengths. For arc lengths, we need to enter the point number and displacement increment. The point number is the location of the load, and the displacement increment I will choose minus 0.05 millimeters per each increment. I just put 0 for the point number to extract the point number. I'm going to the model. Location of the load is 1100 from the left support. Now we can extract the coordinate of each node. Let me label the nodes. It must be here. I will click on the select option, and I click here. The point coordinate is 1137. It was 1100. I will check another one. Okay, I will note this point 1158 as the location of the load, and for the support, faster if I unmark the labeling, it will be, that's fine. I will choose node number 84, 984 for the left support, and the right support, suppose it must be here at 2000. It's not 2000, it's 1800. Okay, point 1045. Okay, now I extracted the coordinates of each point, which are the points for the loads and the points for the supports. Now I will enter the name of the point here in the point number. It was point number 1158 for the location of the load, which the increment of this value in D3, which is in Z direction. Okay, now we can introduce a support. We can just click on this icon in the right panel, or we can choose the supports in the top combo box. This combo box includes all supported blocks by FEMIX PrePost application. I just click on supports. I will see the support table. We need to choose a group. It's FEMIX group, could be FEMIX group or any other name. We have just one phase. The point number is 984. It's in D. It's fixed in D3, and the right one, this is rolled and this is pinned. The right one is, the group name is FEMIX group. The point number is 1045, and it's fixed in D2 and D3. It's a pinned support. Now we see that the supports are visible in the model. From the right panel, we can control the visibility of different parts. For example, when uncheck the support, they will disappear. And also we can control the different groups. For example, a syrup Z, I just unchecked it, and we see that the visibility will be controlled. Also, we have different controlling in the top for example, hide the mesh, also the opacity, and we have different options for shrink the mesh, and also we have another option for moving. They are just the visibility of the model. Okay, that's right. Well, we introduced the support. Now I'm going to put the point load in the model. For the point load, we need to introduce a load case. I'm going to load case parameters. We need to just name a load case. The load case title will be, for example, load 1. The load case group, it could be FEMIX group. Integration must be GLEG, and integration name could be default. Okay. Now we have the load case, and now we can introduce the point load. The point load, the number was 21, was 1158, and the force in Z direction, I will put -1, and the other parameters are 0, and we need to choose the load case which we introduced before, and it was load 1. Okay, now we have the point load, and it's already applied here in point number 1158. Just unchecked it. Okay, the next part is we could define the material here and different properties here before going to element properties, or we can go to element properties and modify directly there. I prefer to go to element properties. We have the list of different parts here, and the element numbers are imported from the mesh section, and the element type are imported also from this previous part, but I need to modify and complete this table. I select this row and go to edit selected row. However, it's possible to modify and choose the parameters here directly in the table, but it's easier to go to edit selected row, and because in this term we can just, it will be limited to the supported elements. For example, here by plane stress squat, it supports these types of material model. I want to use material model 104, and I click on add a new item. Here in this table I can enter the values for the material 104, or I can right click and add a new row. It's easier to understand the concept of each parameter. We can directly enter the parameters in this window, or if we already added a material in our library, we can load them, or we can modify and save them to the library. I already added this material to my library. I just click on the name of material and load it, and we see that the material properties are available here, and the fracture mode parameters, and also the fracture mode 2 parameters, and the other parameters, and out of plane, which is none. Okay, I click on OK, and the parameters will be added to this table, and then OK, and we have the name of material in our list. I choose the material type. The next step is choosing the geometry type. Here in our case, because it's a plane stress, it could be lambda, and the geometry type need to be defined. The geometry type, add a new row. For the web, the thickness of the web is 150 and the flange is 400. I enter 150. I can enter the flange thickness 2 here in this table. Okay. Now I will select the web. The integration type is GLEG, and the integration name doesn't exist yet. I click on this button. I can enter the integration name by entering the keywords, or I just click on add a new row, and I want to use the auto generation. It was a plane stress. I choose plane stress squat and generate the integration, and OK, we have the integration. I want to add another row for embedded cables. It's embedded cable. We're going back to the bottom. Embedded cable 2D, generate, and OK. And we have the embedded cable integration here in our table. OK. So for web, it's plane stress. And I want to change the group name to, for example, concrete, because I want to keep them in one group. OK. Okay, the next one is web 1. I put it on conc beam. I change the group name. The material type is 104. It's the same material and it's the same thickness because it was the web, and the integration type is plane stress squat. Okay. And for the flange, it's plane stress squat. Material type is same as web, but the thickness is different. It's flange, and integration type is same as web. Okay, and the next part is bar on the bottom. It's embedded cable 2D. The material type is, I want to choose linear isotropic material. I want to add a new material. I click on add a new row. I can enter the values directly in this table, but I have already this material in my library. I will select ST linear. I will load it, and we can see that these materials are loaded in our window, and I click on OK. OK. We have linear steel. Geometry type is for embedded cable, we need to define the cross-section area, and the cross-section areas I want to define the cross-section areas for different rebars. I already noted them. For the bottom, we had 3 rebar with a diameter of 18 millimeters. The cross-section area will be 763. Okay, the next one, bar. On the top, I name it as top. It was 2T10. The area 2T10. The area is 157. The next one is a stirrup. It had 2 legs, so it's 2T8, and the cross-section area is 100. The next one is the Z bar. I just name it as Z, and the cross-section area, it was 114, so 154. Let me just put 114. Okay, now I added all cross sections. So for the bar in the bottom, it was 3T18, and the integration type is embedded cable 2D. Okay, the next one, embedded cable 2D. Material type is isotropic. I already added, but for the bottom, I think we need to define. I will modify it later. Geometry type in the top, embedded cable, because in the bottom we had GFRP bar, so we need to define another material here. I add a new material. It will be GFRP bar linear. Okay, this is the properties of the GFRP bar which already exists in the paper. Okay, and I change it to GFRP bar for bar in the bottom, but the top is still linear. We can check in the table the values we already entered. For the stirrup, it's embedded cable 2D, material type linear isotropic, steel, cross section, it was a stirrup is 2T8, and the integration name is embedded cable, and integration type is GLEG. Okay, and the last one is embedded cable 2D, linear isotropic, it's a steel, cross-section area, Z bar, and embedded cable 2D. Okay, we can check the parameters in the table. It seems to be fine. Okay, now we already modified the element properties. We have the supports, we have the load, and we defined the different parts of the model. Now I save the model and run the. Okay, after analysis, we need to go to generating the results. I click on generate the results. Here we have the different combinations. We can choose which group we want and what kind of output we need. For example, we can get the displacement, stress, strain, and crack pattern. If I click on OK, it takes a while for generating the output. Okay, now we have the results. We have different type of results. In the first box, we need to choose the types of result. For example, I want to see the displacement of this beam. In the sub result, we need to choose in which direction we want the displacement. For example, I want to see in D3, and in which step we had 55 step. For example, in last step, I want to see the displacement. This is the displacement of the beam. In the contour, we can see the deformed, undeformed, or both types of deformed and undeformed shape in one single window. I click on to see the both, and I will increase the scale factor, and I will refresh and to see more scale factor. Now we see that we have the deformed mesh, and the type shows that here we have a crack. Let me go to the crack pattern in the beam, and in the last step 55 I will increase the length and width size factor and refresh, and this is the crack pattern. Now we see that we have the crack opening here in this part and the closing near the shear crack, and it shows that we have a shear failure in this beam, and we can control the viewing of the crack in the model. Okay, now we can go to the graph part to draw, for example, the displacement, load displacement graph. In the x-axis I want to see the displacement, and in y-axis I will see the load, which are actually the reaction force, and we need to choose the point number. We can enter the point number and by this format, or I can click on this icon and choose the location. So the displacement, I want to measure the displacement under the load, and the reaction, which I need to click on. I need to choose. And click on this icon to confirm the selection, and for the bottom this point 14, and the next one is 104. Let's check 14 or 104, that's fine. So we can define some multiplier. Because the displacement is minus, I multiplied it by minus to have it in a positive direction, and the displacement and the loads are in Newton, I multiplied by this value to have it in kilonewton. So I can click on plot the graph, and it will take a time, and we have the load deflection curve, and the units are kilonewton, and deflection is in millimeters, and we see the response of this beam. Okay, thank you for your attention.